Good day, engineers! Para sa video natin ngayon, ang i-discuss natin will be the sample problem for the ultimate bearing capacity of eccentrically loaded shallow foundation. So let's start discussing this sample problem. So for our sample problem, ito yung ini-state ng problem natin. Sabi dito, a continuous footing that is 3 meters wide supports a load that has an eccentricity of 0.4 meters. It settles at a depth of 1.5 meter from the natural grade line where the soil is a sand having an angle of shearing resistance of 20 degrees and a unit weight of 18 kN per cubic meter. Determine the ultimate load per unit length of the foundation. So we will have to use the Meyerhoff's method and the Bowles method. So syempre, to start solving the problem, kailangan natin munang i-drawing yung continuous footing na sinasabi dun sa problem natin. So sabi, yung continuous footing is may width which is 3 meters. Ito yung drawing natin. So, ito daw yung width niya na 3 meters. Siyempre, continuous footing yan. So, ibig sabihin, yung length niya is infinite. So, ito yung top view natin. And, it supports a load that has an eccentricity of 0.4 meters. So, yung eccentricity na yon is along the x-axis. Kasi hindi naman tayo pwedeng magkaroon ng eccentricity along its z-axis kasi infinite naman yung length doon. So, ang eccentricity natin is along the x-axis lang which is 0.4 meters. Yung footing daw settles at a depth of 1.5 meters below the natural grade line. So, ito siya. And the soil natin is a sand having an angle of shearing resistance of 20 degrees at ang unit weight niya is 18. So, ang kailangan natin i-determine is yung ultimate load per unit length of the foundation. Siyempre, since this is a continuous footing, ang tendency natin is to analyze this one per meter strip kasi nga infinitesimal yung length niya. So, to start, we'll have to determine first its bearing capacity factors. So, ang una nating isolve is yung bearing capacity factor for our Meyerhoff's effective area method. So, getting the bearing capacity factors, we have here NQ is equal to E pi or E raised to pi tangent of phi times tangent squared 45 plus phi over 2. So, substitute lang natin yung value nung phi natin dito. So, that will be E pi, so tangent 20 times tangent squared 45 plus 20 over 2. So, the resulting value for NQ will be equivalent to 6.3994. So, yan na yung NQ natin. For our NC, syempre ang ginagamit pa rin natin dito is yung bearing capacity factors for Meyerhoff's bearing capacity equation. So, our NC will be coming from NQ minus 1 times cotangent of phi. So, substituting the value of NQ and yung phi dito, we have here 6.3994 6.3994 minus 1. Siyempre yung cotangent, pwede natin siyang i-1 over tangent. So, ibig sabihin meron tayo ditong divided by tangent of 20. So, calculating this value of NC, we have here 14.8347. So, yan yung value nung NC natin. Yung last bearing capacity factor na kailangan nating i-determine is yung N gamma. Our N gamma will just be equivalent to NQ minus 1 times the tangent of 1.4 times phi. So we have here NQ is 6.3994 minus 1 times the tangent of 1.4 times 20. So our N gamma will be equivalent to 2.8709. So yan ngayon yung ating N gamma. So nakompleto na natin yung bearing capacity factors na kailangan natin. Ngayon, punta naman tayo dun sa iba pang required dun sa Meyerhoff's equation. So, may ano yung figure na yan. Punta tayo dun sa cohesion. So, sabi, yung soil natin is a sand. So, ibig sabihin nun, we have no cohesion for sand. Therefore, the C will be equivalent to 0. Ang meron lang tayo will be Q, which is the overburden pressure above the base of the footing. So, kunin natin yung overburden pressure. So, since kukunin natin yung overburden pressure, so that is a Q value. So, kung ano man yung nasa ibabaw ng base ng footing natin, yun yung part ng overburden. So, ang nasa ibabaw lang niya, kung titignan natin dito, is the soil na sand. So, we'll just get the unit weight times the depth of the footing. So, that is just gamma times the DF. So, that will be equivalent to 18 times 1.5. So, the value of Q for this one will be 27 kilopascals. So, our overburden pressure will be 27 kilopascals. Then, after getting the overburden pressure, kailangan natin yung value of the B prime for the third term ng equation. Ito na yung tinatawag natin na effective width. So, for our effective width, syempre, coming from this figure, so, kung mapapansin natin, the eccentricity EX, which is 0.4, is parallel to the 3 meter side or the 3 meters width. So, ibig sabihin, doon natin ibabawas yung eccentricity EX. So, twice of the eccentricity EX yung kailangan nating tanggalin. So, yun yung magiging effective width. So, that will be a value B prime which is equal to 3 minus dalawang EX which is 0.4. Then, we have here the B prime which is equivalent to a value 11 over 5 meters. So, that will be the effective width coming from the principle of the Meyerhoff's effective area method. So, next to determine is the shape and the depth factors. So, sa shape and depth factors, ang kailangan na lang natin kunin is yung lambda gamma S, lambda gamma D, uh, and yung lambda QD and lambda QS. Hindi na natin kukunin yung para kay cohesion kasi 0 yung cohesion. Ibig sabihin, yung first term nung Meyerhoff's equation will also be equal to a value of 0. So, para makuha yung mga shape and depth factors, unahin natin kunin yung passive earth coefficient. So, for our passive earth coefficient, we can use the equation. So, siya yung Kp natin. So, that will be equivalent to tangent squared 45 plus phi over 2. Pwede rin yung equation na Kp is equal to 1 plus sine of phi over 1 minus sine of phi. But for this problem, we'll just use the tangent squared 45 plus phi over 2. So, Kp for this one will be equivalent to tangent squared 45 plus 20 divided by 2. So, the value of the passive earth coefficient will just be equivalent to 2.0396. So, ito na ngayon yung value nung K sub P natin or yung passive earth coefficient. After getting the passive earth coefficient, we can now proceed in getting the shape and the depth factors. So, yun nga, ang kukunin na lang natin will be lambda QS and lambda gamma S and also the lambda QD and the lambda gamma D. So, for the shape factor, we'll just have lambda QS is equal to lambda gamma S, which is equivalent to 1 plus 0.1 times Kp times B prime over the L prime. So, substituting the values, we have here 1 plus 0.1 times the Kp, which is 2.0396, times B prime, which is yung 11 over 5 na nakuha natin kanina, and yung L prime natin will just be infinity since continuous footing to. So then, alam natin that if we divide a number with an infinite number, this will become 0. So, ibig sabihin, our lambda QS times lambda gamma S will just be equivalent to 1.0. So, ito na ngayon yung lambda QS natin and yung lambda gamma S. For the depth factors naman, for our depth factors, we have the lambda QD and the lambda gamma D. So, that will be 1 plus 0.1 times square root ng Kp times df over B prime. So, the lambda QD and the lambda gamma D will be equivalent to, so 1 plus, so 0.1 times square root ng, yung Kp natin is 2.0396 times df will be 1.5 divided by the b prime 11 over 5. So, calculating this value for the depth factor, we have here lambda qd is equal to the lambda gamma d, which is equivalent now to 1.0974. So, yan ngayon yung shape and depth factors natin. So, after that, or after getting those values, we can now have the ultimate bearing capacity equation. So, pwede na tayong kumuha ng Q ultimate. So, syempre si Q ultimate will be from the Meyerhoff's bearing capacity equation, which is the CNC plus the QNQ, or CNC times lambda CS, lambda CD, lambda CI, plus the QNQ, lambda QS, lambda QD, and the lambda QI, plus 1/2 gamma B prime and gamma times lambda gamma S, lambda gamma D, and the lambda gamma I. So, dito yung gamma na gagamitin natin will be kung ano man yung nasa ilalim ng footing natin. Ang nasa ilalim ng footing natin is still the sand itself. So, ibig sabihin, ang gamma na kukunin natin will be the value 18. So, substituting the values, kung mapapansin natin, minumultiply lang yung cohesion. Kaya, hindi ko na kinuha yung shape factor for cohesion and the depth factor for cohesion. Kasi itong term na to will just be 0. Kasi nga, yung cohesion niya, 0. So, ngayon, getting the Q ultimate, we'll just have Q. So, ang Q natin will be 27 times NQ, which is 6.3994, times the lambda QS, which is 1.0, and the lambda gamma S, or the lambda QD, which is 1.0974. Then we'll add 1/2 times the gamma, which is 18, times B prime, which is 11 over 5, times the NQ, which is 2.8709, then the lambda gamma S, which is 1.0, and the lambda gamma D, which is 1.0974. So, calculating this value, we can get the ultimate bearing capacity, or QU na lang, which is equivalent to 251.9934 kilopascal. So, yan ngayon yung ating Q ultimate. So, now for our P ultimate, kasi P ultimate yung kailangan natin. So, the P ultimate will just be equivalent to Q ultimate times B prime. So, B prime na yung gagamitin natin dito. Hindi na siya bilang. Kasi we are on the effective area method. So, to get PU, or the P ultimate, so PU is equal to yung QU natin, which is 251.9934. I-multiply lang natin yan ng 11 over 5. Then, calculating the value, we will have PU is equal to the value 554.3855. So, this is in kilonewton per meter. So, ito na ngayon yung hinahanap nating answer for this problem on the part of the Meyerhoff's effective area method. Ngayon, dako naman tayo dun sa Bowles method. Sa Bowles method, syempre, ang magbabagal lang dito pares pa rin sila ng shape, pares pa rin sila rather ng bearing capacity factors. So, we don't need to calculate or recalculate the bearing capacity factor. Pares lang din yung overburden pressure natin, which is 27 pa rin. Ang magpapalit lang will be RB, which is 11/5. O ang gagamitin na natin will be 3. So, let's try to calculate it by the Bowles method or the method 2. So, for the method 2, so, kunin natin yung B niya will be 3 meters na. And then, hindi tayo magpapalit ng bearing capacity factors. So, the NQ will just still be 6.3994. Yung NC will be 14.8347. And yung N gamma will be 2.8709. So, to determine the ang kailangan kasi nating i-determine dito is yung concentric bearing capacity, which is yung original na Meyerhoff's equation. So, yun din, yung Q natin dito is 27 kilopascals pa rin. So, yung passive earth coefficient natin, K sub P, will still be yung 2.0396. So, ngayon, ang mapapalitan lang is yung shape and yung depth factors natin. So, dako tayo dun sa shape factors. Tignan natin. Sa shape factor natin, so that is still the lambda gamma S or the lambda QS and the lambda gamma S. So, that will be 1 plus 0.1 times Kp times B over the L. So, that is just equivalent to 1 plus, that is 0.1 times 2.0396 times B is 3 divided by infinity. So, as you can see, any number ulit divided by infinity will be 0. So, this means that automatically lambda QS and the lambda gamma S will still be 1.0. Next, for our depth factor. So, depth factor na to. So, for our depth factor, we have here the lambda QD and the lambda gamma D. So, we have here 1 plus 0.1 times square root ng Kp times dF divided by the B. So, lambda gamma or lambda QD and lambda gamma D will just be equivalent to 1 plus, that is 0.1 times square root ng 2.0396 times our dF, which is 1.5 divided by 3. Then, this value will be equivalent to, so lambda Q din natin is equal to lambda gamma D, which is equal to 1.0714. So, yan ngayon yung shape and yung depth factor natin. So, since nakompleto na natin yung mga kailangan natin for the bearing capacity equation, we'll have to calculate for the ultimate bearing capacity for the concentric loading. So, that will be QU concentric is equal to, so that will be yung CNC, lambda CS, lambda CD, and lambda CI automatically 0 pa rin siya dito. So, that is Q and Q na lang, lambda QS, lambda QD, lambda QI, plus, so, 1/2 gamma B and gamma, lambda gamma S, lambda gamma D, and the lambda gamma I. So dito, hindi na natin kino-compute yung lambda gamma I and yung lambda qi kasi automatically, ang factor nun is 1.0 since yung load natin, hindi naman siya inclined. So, for the QU concentric, we'll just have 27 times and Q is 6.3994 times the lambda QS which is 1.0 times the lambda QD which is 1.0714. Then add by 1/2 times gamma is 18 times the base is 3 times 2.8709 times 1.0 times 1.0714. So, yan ngayon yung equation natin, and computing for the QU concentric, we have here 268.1694 kilopascals. So, yan ngayon yung ultimate bearing capacity concentric. So, ibig sabihin, hindi pa yan yung gagamitin natin for our eccentrically loaded. So, kailangan natin siyang i-reduce by using the reduction from the method 2. So, sabi sa method 2, pag cohesionless yung soil, automatically the reduction, so REX yun, kasi along the x-axis yung reduction natin. So, that is 1 minus square root ng EX over yung parallel sa kanya, which is yung B. So, yan ngayon yung equation natin. EX over B kasi ang parallel sa kanya. So, ito yung EX, ang parallel is yung B, which is yung 3 meters. So, to get the reduction, we will have here 1 minus the square root of, yung EX natin is 0.4 divided by 3. So, calculating the RE sub X, we have here 15 minus the square root of 30 over 15. Yan ngayon yung reduction natin. So, to get the eccentric bearing capacity, so the QU eccentric, so that will be equivalent to the QU concentric times REX. So, that will just be a value 268.1694 times 15 minus square root ng 30 over 15. So, the QU eccentric is equal to a value 170.2478. So, this is in kilopascals. So, hindi pa yan yung answer natin kasi ang kailangan natin is the ultimate load or the ultimate load per meter length. So, to get PU, we'll have the QU eccentric multiplied by B prime. So, that will be 170.2478 times the B prime, or hindi na pala siya B prime, sorry. B na lang siya kasi na-reduce na natin yung QU eccentric eh. So, we'll just use D. So, times B. So, that will be times 3. So, the PU will just be equivalent to 510.7433. That is in kilonewton per meter. So, ito na ngayon yung hinahanap natin na isang answer for our given problem. So, that will be all for this sample problem regarding the ultimate bearing capacity for eccentrically loaded shallow foundation. So again, this is Engineer Rodolfo. Thank you for watching and don't forget to subscribe to Butch TV.